Okay, it's almost 1:35. So I think we start now because today's lecture is only covered 1 hour, right? And I need to have 1 more hour to cover the computer application part. So I would like to ask the respective class representative, have you finalized or suggested any time slot? Yeah, because it's quite challenging, I know, because we need to suit everybody's timetable. So anyone, if you want to share anything, you just unmute and then you can say something or type anything there, right? Have you discussed among yourself, because I don't have your respective timetable, Yeah. Wednesday 5 p.m. No, after 5 is not available for me. Still commuting, right? Still commuting. So I think afternoon session or morning session, is it okay? Because I can start as early as 8:30 actually. Just now is Amanda, isn't it? Amanda? After 5 is totally KO for me, still commuting in the highway.
I'm not very sure about that.
Not so sure. Can you please discuss among yourself first so that I hope to conduct that computer application class. I think before Dr. Tan's class, if can, right?
Okay. We will get back to you later. Is that okay?
Yes, thank you. Is it Amanda is speaking just now? Are you?
Yes,
Amanda?
I am. I'm from
Okay, thanks.
Bioresource.
Okay.
Right.
From Bioresource, right?
Yes.
Okay. So please discuss among yourself. Another thing is that one reminder is that I have received from Bioresource Technology, Bioresource, Food Tech and Environmental Technology. What do we call that? The group list from these 3 programs. I would like to confirm: is there no students from Bioprocess Technology? Any students from Bioprocess Technology here? No? Yeah, because I thought it is actually four programs, students from 4 programs are joining. I thought if there's no bioprocess technology, then I need to remove those questions, So would like to confirm here, no students from bioprocess, right? Okay, that's great. Okay, so I will discuss your rule. Yes?
Sorry to interrupt. May I ask, is that okay if we have it for the night class? Because I think morning, each of our, we are in different divisions, so we have our own slot. So since you are commuting back at 5 p.m., so if like set 8 p.m., is that okay? Like during the night session?
Sorry, Amanda speaking, isn't it? 8
Yes.
p.m.
Yes.
I don't think so, night time. So sorry about that. I don't think so.
Okay. It's okay. We try to discuss among ourselves if
Yeah. Can you
we
please
try to
match
see.
match the best first lah? Match the best first. If it is really needed, then I think I need to take maybe Saturday afternoon or what. But definitely no night class. Yeah.
All right. So we will see how if weekdays is not available, then I guess we will need to plan it on the weekend. Because
Can you please jot down? Is it Amanda, isn't it?
Yes.
Okay, Amanda, can you please take a note over there? Maybe you can discuss with maybe food tech and tech students. I think this Saturday, right? This Saturday, 11:30 until 12:30, I can take that hour. Can you please jot down that?
Okay, sure. Sure.
11:30, if it is possible for you all, because I want majority of you attend to this lecture so that you open your own SPSS and then I will teach step by step. because the main objective of this course is that you need to master the skills to run your SPSS, not the theory part,
All right.
right? Okay, so kindly let me know later on, okay? Okay, so today our lecture is talking something on regression analysis. I believe your mind is still fresh because you took IUK 108 before, and I hope you are still fresh with regards to simple linear regression, right? And then the only difference of regression, simple linear, right? And IUK 208 regression analysis is for IUK 208, actually we want to see multicollinearity, some things that you need to know for your theory part. And also we might touch a bit on the multinomial regression. Okay, multinomial means you have more than y x, you have more than yx and not the simple 1x and 1y, right? So this regression analysis will only be tested in your assignment because your assignment, you need to cover that 30 marks. And this regression analysis is the mass analyzed types of analysis in your assignment. We will have a look at your rubric later, okay? So since there is no students from bioprocess technology, so I will just remove the title from that part, and then later on I will upload those respective titles together with their SPSS data set in the eLearn. So each group you need to download the title and also the SPSS data set and do it your own, and do it your own. So for example, environmental technology, there will be only 2 groups. So I will just assign 2 titles, 2 different titles for you to run, to do that 30 marks assignment. So it's all on your environmental technology kind of thing. For example, maybe you want to check about the turbidity, the air quality, the noise level, right? The water quality, all these things, all on environmental, right? Okay, so we go back to our regression analysis. The first part of regression analysis is something repetition of what you have learned in your IUK 108. Okay, we have some refreshing first. We have some refreshing first. So the general idea of simple regression, our main objective for regression is we want to see is there any relation or relationship between a single explanatory variable and another response variable. Okay, let's say we want to see whether the higher the temperature, the rate of evaporation is higher. So even though we know that this is yes, but for this simple regression, if we are not so sure about the trend, let's say I'm not so sure about my trend, is it regression, linear or cubic or quadratic, something like that, we want to check first, is it higher the temperature, then higher the evaporation rate, for example. Then in order to confirm this relationship, we run simple regression. So we expect the relationship is kind of a linear relationship. So I have one explanatory variable. So the temperature is my explanatory variable and evaporation rate is my response variable. So very simple. So then we check about the R, we check the P, and then we check the beta, the significant beta. Right. So we want to see whether X is related to Y or the other way around is Y, is it influencing X? Okay, so what have been covered in your IUK 108 is you want to see one X and one Y. Okay. And then for IUK 208, we are interested to see whether X1 x1 or xy is influencing y or not. Whether or not x1 performs better to influence y, or x2 is better performed as compared to x1. So we want to see in this way. Okay. So when we look at the relationship for regression, it doesn't care whether it is simple linear or multinomial. Multinomial means more than x, more than one x and more than one y. So for your syllabus right now, you want to see one dependent variable and more than one explanatory variable, which means only one y. Okay, more than one y is actually another part of regression, but it is not within your syllabus. Okay, so now we are interested to see whether more than one x is influencing the y or not. So this is so-called the regression model in your syllabus. Okay, so one very important thing is that the y has to be in a numerical form. So when we see the word numerical, it means that it must be represented by numbers. It must be represented by numbers. Let's say preference. We rank preference in a series of ranking. Let's say ordinal ranking. 1 represents dislike the most, and then 10 referring to like it so much. So that 1 to 10 and the intermediate numerical things with the representative decimal points, that one refers to numerical. So 1 to 10 is actually numerical. Another one is something with decimal point, of course. Temperature, 37.5, indicating a lower or mild grade of fever. So 37.5 is numerical. Okay. Let's say whether gender affects the academic performance. Let's say we want to see. So gender, you recode them as, let's say, 1 equals to a male, 2 equals to female. So can this be used in regression models? Can or cannot? Anyone? Anyone have a guess? So when I share in a larger screen, I cannot see your comments, So please don't type the comments over there. You just unmute your microphone and then you give your answer. 1 equals boy. 2 equals a girls. Is gender manners to influence academic performance? So to answer this question, you need to ask yourself, do we have the gender of 1.6? Definitely no, right? So if the answer is definitely no intermediate value, either 1.2 or 1.99, it means this is not a numerical variable. Which means to study gender, the effect of gender, we cannot use regression models. So this is only, this also will be tested in your assignment for regression. Okay, so don't underestimate the power of regression because the model's assumptions is very straightforward. They cannot accept something very strange to them. For example, gender. So 1 is a boy, 2 is a girl. So even though 1 and 2 is the number, the numerical, but in statistics, it doesn't fall into the category of numerical because if we ask ourselves, is there gender numbers equals to 1.6? And if the answer is no, definitely this is not a numerical variable. Okay, so you understand? So cannot. So then why preferences can be used even though our choice is from 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why it is permittable? Because we can indicate our preference according to the level. We know that level 8.7, very much like. If let's say I have 1.2, it indicates that I almost dislike the most. Okay, so this integrates the degree, not a category. So this refers to numerical. Okay, so please be careful when you are doing your assignment, because I will be listing quite a lot of variable. You need to determine which parameter or which variable to be used, and you need to use it correctly. The marks is over there. Okay, so why only one? And then you can have one or more than one numerical or categorical independent variables. So for X, it could be, but for Y, only one. Okay? Right. The use of regression. So I think it is more useful to predict or to estimate. Okay, I believe some of the students, I think in environmental technology program, in your coming FYP project, final year project, some of you, maybe 2 or 3 in one batch, will get some research FYP title, not 100% lab. So some of you will be given some title like to predict the modeling, to give some assumption, to develop a prediction model or prediction equation. So how is it going to be done? It is that they use regression model to predict the future trend of something that is going to be happen in the future. For example, okay, you have a rainfall data. This is so-called estimation and prediction. You have a list of rainfall data. Let's say from 2000 to 2020. Okay, now your objective is to see or predict the rainfall trend, whether which month falls into the category of a heavy rain, from which month to which month is actually a dry season for Malaysia, and then for a specific states. So we can predict using the currently existing data. So first of all, you need to have a list of data. So maybe reported or recorded by the Meteorological Department of Malaysia on the rainfall data. So you have a lot of data. What is the use of this data? To predict and estimate what will be happen in the coming 2 or 3 months. So this is what is actually carrying on by the staff in the meteorological department. They use the past tense data, okay, the past data to predict the upcoming data using regression models. So this is one of the use of regression model for prediction and estimation. Okay. Okay, so now we look at these explanatory variables. So this is categorical independent variables can be incorporated into a regression model by converting them into 0 or 1 dummy variables. Okay, all these things you need to be practice this. You need to practice this based on a list of variables that I'm going to give you later on for your assignment. Okay, so there are a few. For binary variables, code dummy 0 for no and 1 for yes. Okay, so this is for the X variable. Okay, independent variables refers to X variable. Okay, so 0 for no and 1 for yes. Okay, there are 2 conditions to use the condition for no and yes. Okay, if we refers to something bad or good, usually we rank the good as 0 and the bad as yes. Okay, so this is something opposite. Let's say whether or not you are a COVID-19 patient, let's say. No refers to healthy, the non-affected one. 1 equals to yes, I am the COVID-19 patient, let's say. So this is an example how to rank your explanatory variables into category of 0 and 1. So what do you need to think is that some students from my past experience, when they recode the existing SPSS, okay, before I forget, for your assignment, you can freely recode, which means, let's say, the moment when you receive the SPSS data set, there are 8 variables, for example. And then to do your assignment, your group mates think that you need to add 2 more variable. That 2 more variable is actually how to say, modified from the existing variable. For example, you want to recode the thing as 0 for no and 1 for yes. Yes, can or not? Can. So you reintroduce 2 more variables into the data set. Can. Okay. Right. So this is the thing, because when you submit the PDF file as the evidence for your assignment, you need to submit together with your SPSS dataset, because I want to know whether or not some variables has been slashed or added. There are any added variables or not. Okay. So these are the marks. Right. Right. So this is just a refreshment of what is that. So we have regression models, and we have simple, we have multiple. So simple is the one that you have learned from your IUK 208. 1x, 1y, and then for multiple is the one that we want to learn and practice right now. Okay. And then for simple regression, you have linear and non-linear. Multiple also you have linear and non-linear. Okay. Okay. Mm. Okay, so we have some slide to refresh on the simple regression model. Yeah. So this is a typical line for y equals to mx plus c. Okay, y equals to mx plus c. So the blue dot refers to all your data. This is your data. This is all your raw data, your y, your x, your y, your x, your y. Okay. So, and then in order to draw a best fit models, so using that SPSS software, you can ask the software to build this regression line. So this is so-called the y equals to mx plus c. Okay, how to see, how are we going to justify whether this model has a high value of errors or low levels of errors? So we can see from the dot. Okay, this dot, when we compare the dot locations with the reference line, it is very far. This dot, this dot almost overlapping the reference line. Correct or not? I'm comparing this dot and this dot. So you see almost overlapping. What about this dot? This dot, very, very far away from the reference line. So this means that this data is actually a dilution data of these are very, very far away data and very, very near data. Yeah. So we can see that there is possibility for these sets of data to be the examples of outliers, this data and this data. Why? The typical reason is their location as compared to the fitted y equals to mx plus c fit model lines is very far. So most probably, this predicts that when you want to run again or run the second time of your lab work, you need to repeat this line, this lab condition and this lab condition. Okay, actually so many things that we can see from the regression. Okay, so here we have 1x and 1y. Yeah, we have one X and one Y here. Okay. So what about multiple linear model? So multiple linear model, you have a 3D space. For simple linear, it is only 2D because you are looking into X to Y or Y to X the other way around. These are all the same. It's just that the direction is different. Okay. So about multiple regression, you are looking into 2X, two explanatory variable to fit a regression line Y equals to MX plus C. Okay, I have some table to show to you how to see this. Okay, look into the linear regression model. So this is just still the revision, because the syllabus is almost the same. It's just that one more X for IUK 208. So this is the typical example of Y equals to MX plus C. M equals to the slope. So this is, I think, Form 4, Form 4 or Form 5, the Max Modern syllabus. To find the M if Y and X is all are provided, and then the B is the error lah. So also provided. So this is the change in X because here is the X axis, and here is the change in Y because this refers to your Y axis on your vertical line here, and B is the Y intercept. Yeah, here Y intercept. Okay, so this is the common thing that you have learned so far. Okay. Okay, so for simple linear regression, we have one added value, which is this one. This one refers to the random error or residual. So when we look at the equation for Y equals to MX plus C, if we see that this epsilon, we call it as epsilon, the value of epsilon is very, very high. So it predicts that error is there and the error is too much. That makes you to reconsider whether or not you need to rerun your experimental setting. So the residual cannot be so high. If it is so high, it is actually indicating that something's error there. Yeah, is something error there. So for your syllabus, you need to write this epsilon in addition to the conventional Y equals to MX plus C. Okay. Right. Okay, the Y equals to MX plus C in regression, we call it as the least square line. The least square. Okay, least square means that when you square them out, you are hoping to get the minimum value. The smaller the value it is, then the more accurate your data is, and the more fit your regression line will fit into the graph later on. Okay, so if you have a very, very low sum of square difference between the points and the lines, just now the points and the lines, very, very much overlapping with the lines, then you say that, oh, this curve, this line is perfect, is approaching the perfect thing. This is what we want, especially if you are running a standard curve. Yeah. Okay, this is what we meant. So this dot, so all these dot referring to one data, So how many data in this model? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n equals to 11. And if we compare whether or not the line is a good fit of line or not, we want to see whether all dots are approaching the straight line or not. This is very approaching. This is kind of far away. This is kind of far away. So all these are residual. So the blue color thing refers to the residue. This one. So this residue is higher. This has a very minimum residue. This one also minimum residue. This is high a bit. Right? So these are the line. This is the line. So when we say The least square or the reference line is the line whereby your data very much approaching this reference line. And we can see that this line doesn't fit, doesn't fit into the definition of a good line because it is actually a mix of a good line, a good dot, and a not so good performing dot because it is located far away. Okay, right. Okay, I have one table. Okay, not yet. Okay, look at this. The total sum of square is equal to SSR plus SSE. Okay, for your assignment, I do not want to see all these formula. All these formula, please do not insert or add into your results part. Please do not add into your results part because this is not part of your marking. This is just to explain and this is all the theory part. So I don't want to see the theory part. I want to see your output. So the output shows that you run the test and you need to show me how well you perform the regression test. I don't want to see the theory. Okay, so all this theory, please. If you want to add this, you need to add into the literature review part and not the results. Results just report what do you found. What did you find from your results, from your statistical analysis? If you want to put this, you need to put, not the method. This is putting, this needs to be put, if you want to put, this needs to be placed under the section of literature review, not the results. Right. Okay, have a look at this table. Okay, now we want to see the why first. Dependent variable is competitiveness. Competitiveness means how well you can compete with each other to get something. Yeah. So you have one Y. How many explanatory variable in this model? Vocab, IQ, sport. Okay, they want to see. Is there any relationship? So now you see my word is there any relationship? No more. Is there any significance, mean difference? No more. Because now I'm testing on regression. I'm not testing on two-way or one-way ANOVA. Okay? So here, the model would like to test whether vocab is related to competitiveness. Is IQ, higher IQ or lower IQ, will give you more competitive? Or maybe if you perform a very good sport performance, or you are actually very bad in sport performance, is it one of the parameters to affect your competitiveness? So you have three explanatory variables in this model, and only one Y, one response variable, which is the competitiveness, right? Okay, here we call it as the predicted variable. What we want to predict, whether you are having a higher competitiveness or a lower competitiveness. And all these factors, we call it as the predictor. Whether or not this influence this, is there any relationship, and we want to see the direction. Is it R, the R value, is it positive or negative? Yeah. So this is how we put here. Okay, next. So this one is just a repetition. I want to repeat something on coefficient of determination. Yeah? This explains to you how high is your strength, whether it is a poor relationship or a very strong relationship. Whether or not this relationship is poor or strong, we call it as the strength. The strength is the terminology that we would like to use. We have this R capital square, the capital R square. Okay, we call this as coefficient of determination. Okay, and you need to remember this. The coefficient of determination is also R square. So here, our R is the small r, the small case r. So in general, if your R square approaching 1, Approaching 1 means, let's say 0.899, 0.934, 0.799, all these representing a higher strength, which means the relationship is firm. This is a very strong relationship. And at the end, let's say if you see your small case R square is very low. So very low means maybe 0.214, 0.117, something like that. So this is a poor relationship. And the high value of R square also indicating whether or not you have a significant data. So usually, in an usual way, when your R small case R square is high, almost or approaching or more than 0.8, you can easily predict that your P is less than 0.05. So if your your small R square is very low, 0.3 something, you can easily predict that no, the results will be not significant. Okay, so this is the way that we predict by looking into the coefficient of determination. Yeah. Right. Okay. Again, theory is not important. What I want to see is this. Okay, look at the results here. Just now we are using a new example here, right? Okay, we have one predictor, exercise. Exercise is our predictor. So predictor means what? Our X. We have one X here. Yeah. And then when you run regression at the end in your output, SPSS output, you can easily get this model summary. I believe you see this before. You have seen this before, because this is something anytime if you click regression, these are the things that you will see the model summary. Okay, first thing we want to see the R square. R square. So this square is spelled out. Yeah, it's spelled out. Sometimes it is not spelled out, but replaced with R and then a square. It depends on which version of the statistical analysis that you are using right now lah. Yeah. Okay. Right. And then, okay, have a look at this. 54.9%. From where we can see this value? This is also another way, or this is extra marks given place for you to complete or to submit your assignment. So this 54.9 is referring to the R square value. So this R square value, if you want to report in terms of R square, then we write 0.549. But the same data, when we report it in percentages, so that everybody understand what are you talking about, we need to say as 54.9% of the population has COVID-19. This is something that everybody understand. So when you say R square equals to 0.549, I would say in this world, only a small portion of people will understand what are you talking about. In order to deliver the better communication, you can change it to become 54.9 of the population, blah, blah, blah at the back. So this blah, blah, blah referring to your title, referring to your assignment title. So this is a very important key point. I hope everybody understand this one. You need to write in this way. Okay. And we have one thing here. I'm not so sure whether IUK 108 has already covered this already or not. We have adjusted R square. Usually, in a common way, the value of adjusted R square is smaller as compared to the R square. Okay, the reason behind this is R square only looking into your data. They do not consider whether or not is there any dilution effect, whether any other covariate also considered inside. No. Adjusted R-square did this. They considered a lot of noises. They kick out and remove a lot of noises to affect your statistical test. So even though they want to show you one thing, the main function is that they want to show you if your data is significant, even though I have already removed all this noise, with the data, my data is still significant. So here you can compare. R-square, 54.9%. Adjusted R-square, I can see 49.3%. So usually in a common case, there are some assumptions, but unfortunately is a PhD in computer science or statistics thing, okay? So adjusted R-square is smaller than the R-square value. Right. Okay, so this thing, if your statistical variable shows this trend, you please report. This is where the added marks will be given to the assignment. Okay. Okay, I already covered this. Okay, now we look at degree of freedom. We look at the F ratio and we look at the P value. SIG dot means your P value, your significance value. Okay, now you see predictor is your X. Let's say this model only one X. This model only one X, which is exercise. Only one Y, which is your Y, is the stress. So one X, one Y. So this is a typical example of simple linear regression. What they want to test, the model wants to test whether exercise relates to stress. Does it mean that if we have more exercise practice, a lot of these are badminton, football, and then basketball, ping pong, swimming, all these exercise will kind of increase your stress or reduce your stress level. So there must be a tester for stress. There must be something, a scale to test your stress level, a stress index, for example. Okay, so this is the results when we look at the F ratio and we look at the significant value. So first of all, we look at the F value. So the F value is 9.735, right? And the significance value is 0.014. So we know already, if you can see the P value is less than 0.05. So this is much more lesser than 0.05. 0.014 is considered less than 0.05. This is significant, which means what? Exercise is strongly related to stress. But can I say that more exercise, more stress, or more exercise, reduce stress? Can I conclude like this by looking at this ANOVA table? Cannot. Why? Because I don't know the R value. R value, the small case r, will tell me whether my direction is positive or negative. Positive means both of them also high. Negative means one going up, another one going down. Okay, so I know already there must be some kind of relationship, but I cannot do my conclusion yet. I cannot draw my conclusion yet because of I don't have the Y value. Yeah, okay. So this is important. So all this output needs to be copy and paste into your assignment. I repeat, this output needs to be copied from your SPSS output, copy and paste as evidence for your conclusion. Yeah, I hope everybody listen to this sentence. Yeah. Okay, so this justify from where you get this value so that I understand, I agree to your conclusion. If I cannot see this, if you just mention in a sentence or text or redraw your own table, this is not the evidence that I want. I want you to copy the original SPSS output from your data. Okay, right, everybody understand, eh? Okay. Another important thing I want to see that is already be introduced in IUK 108, but the emphasis is not there yet. This is very important for everyone when you do your final year project later on. Yeah? We have one terminology. It's called standardized beta coefficient. Where is it? Have a look at the table. Ne? We have two things also. One is the unstandardized. Another one is the standardized. So you see, just now, this is the ANOVA table. Even though you are running regression model, you still get the ANOVA table. Okay? And then another one is this one, coefficient table. This table is also very, very important. You see, the p-value is 0.014. We look back here. In ANOVA table, the p-value is the same. Okay, so these two things are sharing the same p-value. Actually, they are referring to the same thing. It's just that this one, they are emphasizing on the beta. We call it as beta. So this B is the one that we can find in our, let's say you are using Microsoft Word. If you click insert and then symbol, hello, is everyone understand? Is everyone understand what am I talking about? What is this beta? You understand or not? The alpha, beta in your Microsoft Word. If you click insert and then symbol, you can choose alpha, beta, gamma, omega, all these things, isn't it? So this beta refers to this one, beta. This is the symbol. This is the symbol. So, but in your syllabus, you only learn unstandardized coefficient. So this unstandardized coefficient is what? What is this? This is your M. This is your slope. Remember, the Y equals to mx plus c. Stress is your Y. M, the slope, is your unstandardized coefficient, the beta here. X is your X, your exercise, X. C is your epsilon, your error, your residual. Y equals M S X plus C. So how do I know my Y is stress? Looking into the title, looking into the question, the hypothesis. How do I know? Ne? The table already mentioned ma. Dependent variable is stress. So stress, why? How do I know the exercise is my X? Ne? The exercise ma. This is the tested variable. This is the dependent, which means the responding variable. They want to see whether this affecting this. Correct or not? In your assignment, you please come out and develop your own standardized coefficient model. This one, I want to see this one. Together with copy and paste this table from your SPSS output. Okay, and they are sharing the same P. So P, even though you see there are two values over here, right? How do I know which one I need to choose? You need to choose the X lah. Hello, X is exercise, isn't it? It is the lower line here. So exercise is everything this line, You don't copy this one. This one is not your manners, not your business. Okay, so P 0.014, T value here, and your beta value here. And at the end, you need to develop this formula for me, together with plotting the Y equals to mx plus c curve. How to draw? Later lah, computer application. Understand all this? So this is important. I know everybody understand relationship, but to apply it, and you need to remember all the steps until you are doing your final year project. That is the application part. Everyone can memorize things without missing any single verb or nouns. I know everyone can digest and then vomit out. I know everyone can do that. If you want to memorize, for sure everyone can. But in terms of application, it doesn't mean that everyone is good. It's the same theory, what? Biology, something, the theory that maybe if you can memorize, then you perform better. Let's say. But this is not the same. This is not the same thing. as you compare with those who are really applied kind of people. Applied kind of people means those are problem solver, those they can think spontaneously, they are not memorizing from the book. So this is the applied thing. Okay, right, this one. Okay, and then we have multiple linear regression. Right, so many X, and then they show some kind of relationship with one Y. Okay, but for your assignment, I only emphasize on more than one X and then only one Y. Okay, right. Okay, one more thing I want to see is that the multicollinearity. This one I already covered, you know. I don't interested in theory part, because for my part, no theory will be tested, not at all, right? Where is the multicollinearity? Okay. This is also very important. I want to see everybody to apply this concept in your regression assignment. Okay, multicollinearity is a condition in which at least two independent variables are highly linearly correlated. It means what? So in your regression, if the assignment title is you have 2x and 1y, okay, you have 2x and 1y, then before you run the regression, first of all, you need to click the multicollinearity to see how high is the value of multicollinearity first. Multicollinearity means we want to see x1 and x2, how high is their relationship. X1 and y cannot be tested because now we are not interested to see the relationship. Okay, right. So let's say you see y and y, of course, will generate one allele, the value of 1. Y and x1, you have this value. Y and x2, you have this value. The most important parameter that we would like to see from the concept of multicollinearity is x1 and x2. You remember, this one, you need to do this. We will have application from what I have delivered today one by one in our 1 hour computer application tutorial later. Yeah, the most important one is the value to test x1 and x2. This one, because this referring to some indication. Okay, to give you some hint whether or not you still can run your regression analysis or not if you have this value. Okay, so I think I covered all. Okay, I need your help. I need your help to finalize your 1 hour slot to me. Yeah, Amanda, and then maybe Jerome and the NTech representative. Yeah, so please do that so that I can get early preparation. Okay. So the attendance, I figure out for the past session, a few of you have forgotten to click your attendance, and then when I check back what I have screened through from the participant list, you are there. You were there, so I just mark you absent. You were present. Okay, so I actually set until 3 o'clock for you to key in your attendance. For those who have yet to do so, you please quickly, right now, click your attendance, because starting from this semester, unit peperiksaan is looking very much attention into your attendance, you know. So I cannot help at all if you fail during your attendance part. If you fail for your attendance, nobody can help you. Yeah. Okay. Right. So with this, I thank you so much for your attendance and attention today. So you need to let me know your preferred time slot, and then I need to match mine one. Okay. I have already pasted the rubric. You please have a look, and then we will discuss together during the computer application part, and which part in your SPSS output needs to be copy and paste, which one is the evidence from what you have obtained from your results, and how to discuss what does it mean. So we will cover all this in our upcoming computer applications tutorial. Okay? Okay? Right. So thank you so much for your attendance, and thank you so much for your alert of this 1:30 class. I know I affect some of your lunch time. So sorry about that, because I have some audit thing I need to cover and I cannot choose my own time slot. Yeah. Thank you so much for your understanding. Okay, with that, can I ask everyone to exit the meeting line, the meeting room now? Right. Thank you so much, everyone.
Thank you, Doctor.
Thank you,
Dokter.
thank you. Thank you, welcome. Thank you, thank you. Kenapa ada muka bergelak ni? Yeah. Right.